So this is a continuation of section 2.2. And just to review what we did in the last video, the end behavior. To determine the end behavior, we need the degree, which is 5, and that's odd. And the leading coefficient is 1, which is positive. And so in the last section, we were looking at these examples. So if the degree is odd and positive, then the behavior would be like this graph. So we can say that the graph rises right and falls left. On this one here, we said we need to make sure this is multiplied out. So we get x cubed minus 3x squared. So the degree is actually 3 and the leading coefficient is 1. So that's odd and positive. So the behavior is going to be the same. And then the last one here, we have x times x is x squared plus x times x minus 3. X squared times x is x cubed minus 3x squared plus x squared minus 3x. Gather your like terms. So you can see here the degree is still 3 and leading coefficient is positive 1. So again, same behavior as this one here. What we want to look at today in this video is going to be what happens at the zeros. So notice that the graphs behave differently at each x-intercept. Sometimes the graph will cross the x-axis and sometimes it touches and turns around. So what I mean by that is if you observe this 0 here, the graph is actually crossing the x-axis. But if we look at this 0, the graph is touching the x-axis and then it turns. And so our goal is going to be to figure out when and why that happens. So example 7, evaluate the graphs below and state whether the graph crosses the x-axis or touches the x-axis and turns around. So if we observe here, my zeros are at x equals 2, x equals negative 1, and x equals 4. And notice that the graph is crossing at each of those x's. In the next picture, we have x is equal to negative 2 right here, x is equal to positive 2 right here, and then we have another x equals negative 2. And at negative 2, it touches and turns. Over here, it crosses. The last one, x equals 0, is here. X equals 2, x equals negative 2, and then we have another x equals 0. At x equals 0, it touches and turns. At the other 2 points, it crosses. So we want to know what happens with these graphs. So notice in the first graph, the zeros were only repeated one time. So there, in other words, there was only one of these, and one of these, and the graph crossed at each point. Over here, we had x equals 2, it repeated once, so it only crossed here. But at x equals negative 2, I have 2 that are repeated, and so it touched and then it turned. And over here, I had x equals 0, and that's where it touched and it turned. Okay, so our definition is going to be related to how many times something repeats. So let's look at the definition. A factor x minus 8 raised to the k greater than 1 yields a repeated 0. X equals a, and we say it has multiplicity k. Multiplicity just means how many times it repeats itself. When k is odd, the graph crosses the x-axis, and when k is even, the graph is going to touch and turn. Okay, and so k is just that degree of the factor. So we'll look at some examples. Okay, so it says find all real zeros of the polynomial function, determine whether the multiplicity of each zero is even or odd, and how many turning points the graph will have. Okay, so the first thing is they want us to find all the zeros. So remember that to find all the zeros, we let y equal 0. Try to factor this. Notice that they all have at least an x squared. So I'm going to factor out an x squared. So if I take factor out an x squared from the first term, I end up with x squared. Factor out an x squared from the second term, I end up with x. And then we end up with 30. Okay. So now we have x and x. So 30, I can be found by 5 times 6. I need the coefficient in front of x to be a negative. So that means 6 should be negative and 5 will be positive. So I have 0 is equal to x squared, 0 is equal to x plus 5, and 0 is equal to x minus 6. So once we have the factors, we can set them equal to 0. Remember that 0 equals to x squared is the same as 0 is equal to x, and 0 is equal to x. So we can separate it as 2, and then we can subtract 5 on both sides and add 6 on both sides. So my zeros here are these 4 zeros. Okay, so I'm going to make a little chart here, zeros, and then we're going to need to know the multiplicity. And we need to know if the multiplicity is even or odd. And then we have to decide if it touches or crosses the x-axis. Okay, so our first zeros are x equals 0 and x equals 0. Then I have x equals negative 5 and x equals 6. Okay, so the multiplicity means how many times did it repeat itself. So we ended up with 2 zeros. The multiplicity here is even. So according to the definition, when k is even, then the graph is going to touch and turn. So since the multiplicity is even, then we say that it touches and turns. And then for x equals negative 5, the multiplicity is 1 because we only have one negative 5. This multiplicity is odd. So if the multiplicity is odd, then it's going to cross. X equals 6, it only occurs one time, so we say the multiplicity is 1, which is odd, so it's also going to cross. Okay. And so basically what's going on here is, let me write it on a piece of paper, the information we have so far. If we look at the behavior, this behavior here is leading coefficient is 4 with a positive 1. So that's going to be going up like this. So if I was to graph this, my zeros are at x equals 0, x equals negative 5, and x equals 6, which is right here. Okay. So we know that the graph is going to rise on both sides. Now at x equals 6, it's telling us that the graph is going to cross, so this is going to come down. And at x equals negative 5, it's going to cross. And then at x equals 0, it's going to touch and turn. So the graph might go something like this. Okay. So let's look at the actual graph so that we can see what is happening. So we have x to the 4th minus x cubed minus 30x squared And so again, you can see at 6, the graph is crossing. And at -5, the graph is crossing. At 0, the graph touches and then it turns. Okay, so that is the information that we're looking for, because at the end, we're going to be able to graph the entire graph with this information. So let's try the next one. Find first the zeros. So I let g of t equal to 0. So 0 is equal to, here we can factor out a t. So if I factor out of t to the 5th, I end up with t to the 4th minus 6t squared plus 9. Okay. We can try to factor. Since this is quadratic, a multiple of 2, I can try to factor this as t squared times t squared is t to the 4th. To get 9 would be 3 times 3, and it needs to be a negative and a negative to give me -6. So I can separate this now as 0 is equal to t, 0 is equal to t squared minus 3, and 0 is equal to t squared minus 3. So I end up with 0 is equal to t. I would add 3 on both sides, take the square root. So t is equal to plus or minus the square root of 3. And on this side, same thing. Add the 3. So t squared is equal to 3. Take the square root on both sides. So t is plus or minus square root of 3. So if we list our zeros, my degree is 5, so I should have 5 zeros. So 1 0 is at t equals 0. Then I have, for this t, I got square root of 3 and negative square root of 3. And so I'm just going to make this a positive one. Since I have a positive square root of 3 here and a positive square root of 3 here, I wrote it twice. And then I ended up with a negative square root of 3 and a negative square root of 3. So multiplicity, I'm just going to call it MULT. And then whether it's even or odd. And then if it touches or crosses. So the multiplicity of 0 is 1 because it only occurs one time. So that's odd. Since this is odd, it's going to cross. The multiplicity of square root of 3 is 2. Since I have 1, 2. The number 2 is even. So this is going to touch and turn. And for this one, it's 2 as well. So this would be even. So it's going to touch and turn. On the next one, let me go ahead and rewrite it. H of x is x squared minus 2x plus 1. Find the zeros. We let h of x equal 0. We can try to factor. To get 1 is 1 times 1. And I need this to be negative. So this would be a -1, and -1 would give me -2. Set each factor equal to 0. So x is 1 and x is 1. So my zeros here are x equals 1 and x equals 1. My multiplicity is 2 since it appears twice. So that's even. So that means that it's going to touch. Okay, and then letter D. Notice these are already in factored form, so we still need to solve for the x-intercepts. So I can set each factor equal to 0. Okay. So here I end up with subtract 3 on both sides. So we end up with x equals -3. This factor can be written as 0, x minus 2, since there's two of them, x minus 2. I can set each factor equal to 0. So x is equal to 2 and x is equal to 2. A shortcut here is you can see if the exponent is a 2, then you'll have two answers. And it's going to be the opposite of what's in here. So if you see negative 2, the opposite is positive 2, because then we're going to bring it to this side. So for example, here my degree is 3, so whatever answer I have, I'm going to have 3 answers. And it's going to be the opposite of this, which is negative 1. And the reason is I can rewrite this as x plus 1, x plus 1, x plus 1. So if I set each one equal to 0, so I subtract 1, and you can see I get 3 of these. Okay. So we need to know if it touches or crosses. Since x equals negative 3 appears once, then the graph is going to cross. And the multiplicity is 1, because it only occurs one time. Here the multiplicity is 2, and so it's an even multiplicity, so it's going to touch. And here the multiplicity is 3, since it appears 3 times. And so 3 is odd, so that means that at x equals negative 1, the graph is going to cross. On the next page, find a polynomial function that has the given zeros. So now they give me the zeros. So they're giving me these answers, and our goal is to find the actual equation. So the first thing to do is rewrite this. Here they give me the zeros. So I'm going to say x is 0, x is 1, and x is 6. And since we're working backwards, we need to know what the factors are. To get the factors, we're basically taking this number to the left side. So I'm going to have here x minus 0, which is just x. If I take the 1 to this side, then I get x minus 1 and x minus 6. So those are my factors. So I'm looking for a polynomial. I don't know what my leading coefficient is, so I'm going to call it an. And then I'm going to use my factors. So we have x, x minus 1, and x minus 6. And so I just need to multiply this out. So here we get x times x is x squared. X times negative 1 is negative x. And I keep multiplying out. X squared times x is x cubed. X squared times negative 6 is negative 6x squared. And negative x times x is negative x squared plus 6x. Gather your like terms. Negative 6x squared minus x squared is negative 7x squared plus 6x. Okay, so here our leading coefficient. In later section, we'll be able to figure out the exact leading coefficient for the problem. Okay, so for now, if you use 1, then if the leading coefficient was 1, this would be your answer. If it was a 2, you would have to multiply it in. Okay, for the next one, we have our zeros. Our x equals negative square root of 2 and x equals square root of 2. So my factors are, take this to the left side, so we get plus square root of 2 and minus square root of 2. So I'm going to have my polynomial is equal to some leading coefficient of x plus square root of 2 times x minus square root of 2. We want to multiply this out. X times x is x squared. X times negative square root of 2 is negative x square root of 2 plus x square root of 2 minus square root of 2 times square root of 2. And that's going to give me square root of 4. So p of x is equal to an x squared. These become 0 minus square root of 4. The square root of 4 is 2. And again, the leading coefficient we'll be able to find in later sections. The next definition, if 2 points are opposite sides of the x-axis, we can confirm that there's going to be a 0 between them. And so, for example, this is what it means. Here's 1 point, here's 1 point. So no matter what happens, there's going to be a 0 in between them if they have opposite signs or on the opposite side of the x-axis. Let f be a polynomial function. The intermediate value theorem states that if f of a and f of b have opposite signs, then there exists at least one value c between a and b. So that's just saying the same thing. F of a and f of b are the y values of these 2 points, and there's going to be a 0 in between. So example 10, show that the polynomial has a 0 between -3 and -2. So for this, we would evaluate the function at f of -3. So I'm going to substitute -3 and for each x. So -3 cubed is -3 times -3 is +9 times -3 is -27 times 3 is -81 plus 30 plus 9. So this comes out to -42. Then we need to evaluate f of -2. So -2 times -2 times -2 is -8 times 3, -24 plus 20 plus 9. So f of -2 comes out to 5. Okay. So again, all this means is since they have opposite values, one is negative and one is positive, then there exists a 0 between x equals -3 and x equals -2. So at x equals -3, this is -3, our answer was -42, so somewhere down here. And at x equals -2, the answer was 5, so somewhere up here. So if you notice here, in order for this graph to connect, eventually it's going to cross at this point that's in between them. Okay. So is there any zeros between x1 and x4 for the function listed here? So again, we would have to do the same. Evaluate the function at f of 1. So let me just write the function. So f of 1 would be 1 cubed minus 5 times 1 squared plus 3 times 1 plus 6. So we get 1 minus 5 plus 3 plus 6. And so this comes out to 1 minus 5 is -4 plus 3 is -1 plus 6 is 5. And f of 4, so we get 4 cubed minus 5 times 4 squared plus 3 times 4 plus 6. So 4 cubed would be 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. 4 times 4 is 16. Times 5 is 80. Plus 12 plus 6. 12 plus 6 is 18. So 256 plus 18 is 274. minus 80. So here you're going to see that this is going to come out positive. So 274 minus 80 is 194. So there is no zero between x equals 1 and x equals 4. And we say there's no zero because they both ended up being positive. So now we can put everything that we just saw in this section together to graph a polynomial. Okay. So these are the steps. Apply the leading coefficient test, which is just the end behavior. So basically, does it rise and fall? Find the real zeros. So for the real zeros, remember we let y equals 0 and solve for x. Find the y-intercept. We let x equal 0 and solve for y. And then plot additional points. So the first thing to do is find the end behavior. So the end behavior for this polynomial is going to be, let me just write it out. We need the degree and the leading coefficient. So here I'm going to have, I can rewrite this as 2 times x plus 2, x plus 2, and x minus 3. So if I was to multiply all the first terms here, I get 2 times x is 2x squared. Sorry, 2 times x is 2x, times another x is 2x squared, times another x is going to be 2x cubed, plus a whole bunch of other stuff. But right now we're just interested in the first term, so the degree is odd, which is 3, and the leading coefficient is positive, which is 2. So my behavior is going to rise right and fall left. Okay. Then we want to find the y-intercept. So for the y-intercept, we let x equal 0. And so I end up with 0 plus 2 is 2. 0 minus 3 is negative 3. 2 squared is 4 times 2 is 8 times negative 3 is negative 24. So my y-intercept is 0, negative 24. Then we need to find the real zeros, which are just the x-intercepts. So I'm going to let y equal 0. So I can set each term equal to 0. So I get x equals 3 on this side. And here if I divide by 2, I get 0 is equal to x plus 2 squared, which I can rewrite as x plus 2 times x plus 2. So x is going to be negative 2 and x is negative 2. So at this point, since it occurs one time for x equals 3, then the graph is going to cross. And here, since I get two negative 2's, then the graph is going to touch. Okay. So those were the first 3 steps. So I can plot these 3 things or work with these 3 things. So we have at x equals 3, a 0. At x equals 2, negative 2 is another 0. And then my y-intercept is going to be at negative 24. So I'm going to go by 5s here, negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, and so on. So negative 24 is going to be right here. Then we know that the graph is going to rise. So I encourage you to use a pencil first so that you can adjust your graph later. Okay, so here at this point, x equals 3, the graph crosses, so it's going to look something like this. And then at x equals negative 2, it's going to touch and turn. So right now the graph might touch, let's apply the end behavior first. So the end behavior is it rises to the right. So that's going to go up like this, and it crosses, so it comes down. And then to the left, it's going to fall left. So this graph is going to come this way. And at x equals negative 2, we know that the graph touches. So it's going to be going something like that. Then we need to figure out any other points in between here. So we can choose additional points. That's step number 4. And to figure out exactly what happens with the graph. So I'm going to use negative 1 and positive 1 to figure out extra points. Okay, so extra points to make our graph better. So f of negative 1 would be 2 times negative 1 plus 2 squared and 1 minus 3. So f of negative 1, if I evaluate it, comes out to negative 8. So at negative 1, I get negative 8, which is maybe around here. Okay. And then let's look at f of 1. So f of 1 would be, plug it in, 2 times 1 plus 2 squared, 1 minus 3. So f of 1 is 2. 2 plus 1 is 3 squared is 9. And 1 minus 3 is negative 2. Negative 2 times 2 is negative 4 times 9. F of 1 is negative 36. So f of 1 is going to be down here somewhere. And then we can try 2 just to be sure. And that comes out to negative 32. So f of 2 is going to be a little bit higher. So maybe like right here. And so now we're ready to complete our graph. So our graph is going to go here. It's going to touch, come down, and then go up. Okay. So let's try the last one here. So we have the next one. We can look at the end behavior. So again, for the end behavior, the options, remember, is you can have x squared, something that is behaving like x squared. Maybe it behaves like negative x squared, or it behaves like x cubed, or it behaves like negative x cubed. So in this example, our degree is 3, which is odd, and our leading coefficient is 1, which is positive. So the behavior is going to be like this here. So we can say that the graph rises right and falls left. Okay, so that's for the end behavior. The y-intercept, we let x equal 0. So anywhere you see an x, we plug in 0. So g of 0 is going to be 0. So my y-intercept is at 0, 0. The x-intercept, or the zeros slash x-intercept, they're both the same name. We let y equal 0. And solve for x. So here they have an x squared in common, so I can factor out an x squared. Factoring out an x squared from x cubed leaves me with x and 3. So I get 0 is equal to x squared and 0 is equal to x minus 3. So I can rewrite this as x times x. So x is equal to 0 and x is equal to 0. And for x minus 3, we get x equals 3. The multiplicity of x equals 3 is 1 because it only occurs one time, which is the multiplicity of 1 is odd. So that's going to cross. And x equals 0, the multiplicity is 2, and 2 is even. So it's going to touch and turn. So let's plot what we have so far. So we have our y-intercept is at 0, 0. Our x-intercept is at 0, 0. And then we have x equals 3. Okay, so we have these 2 points. Again, I like to use a pencil just to sketch the graph briefly. So my behavior rises to the right. So this is going to go up over here. And it falls left. So this is going to go down. At x equals 0, it touches. So that means it's going to touch and turn. And at x equals 3, it crosses. So it goes something like this. So we need to figure out what's happening in between these two zeros. So I have 1 and 2 that I'm going to use as my extra points. So if I use 1, then we get g of 1 is equal to 1 cubed minus 3 times 1 squared. So we get 1 minus 3 equals negative 2. So negative 1 or positive 1 gives me a negative 2 right here. And then I'm going to use g of 2. So we get 2 cubed minus 3 times 2 squared. So 2 cubed is 8. 2 squared is 4 times 3 is negative 12. So we get negative 4. So we go 1, 2, 3, 4. So now I can use this information to plot my graph. So I'm going to go from this point here, will come down, and then it's going to go up. Let me erase the pencil. And so that would be our sketch for our graph. Okay, so that's the end of section 2.2.